My name is Charles David Napier II. I'm from Breathitt County, and my grant was for a program called Programming into the Future, building robots to prepare students for the jobs of tomorrow. Um, this is an overview of what I'm going to be discussing during my presentation, and basically, this year was a building year. I've done this project in years past. I've been trying to build a strong robotics program in our school. Um, so I requested money this year to get more material so I could get more kids involved with the program. So the big area that I was focusing on was improving students' skills in mathematics, making them more fluent, better problem solvers, just stronger all around in mathematics, because that's the core subject that I teach. And what I did is I had a semester-long class with about 24 students in it that I primarily focused on with these strategies. What I found was students are most often given closed questions with limited answers and limited rigor. Presenting students with open-ended situations allows them to think on a higher level, and it fosters creativity. I found that better problems result in better problem solvers, and that open-ended problems improve students' abilities to apply mathematical concepts. My plan of action. This is what my students did. They assembled the electronic components of a programmable robot. They engineered and designed a robot that could be used in real-world problem situations. They used principles of engineering to improve the performance of their robot, and they applied the components of STEM learning to real-world problem situations. So I did bring some pictures of some of the stuff my students built. We partnered with Lego, and we acquired a big map that we built obstacles and constructed around it. And the theme was recycling, cleaning up after a disaster. Okay, so the students, they program robots to pick up trash, to put things in recycling bins and reuse them and reprocess them. And they had a really good time with that. So I want to just show you some of the things they built. These are actually Link's Motion robotic systems, and they built 2 track systems, and those could climb stairs. Those were actually able to climb stairs. In the corner of my classroom, we built a BattleBot arena because we did want to just have outright fun with it. So we built this arena in the corner, and the students later on in the semester could just create an original robot, put them in there, and let them fight. I mean, it was fun. They had to use math in order to make it successful. They used if-then statements, conditional statements, so it was really, really neat. Unfortunately, during the snow, our roof leaked and it got all over our arena. We had to pull it up, but it was great while it was there, and it'll be back down next year. This is an example of our Lego mat with the obstacles. This was like a reusing station where students could program robots to input things in here and pull new things out. This was another recycling bin, and they built all of these obstacles, but they did come with instructions. So these aren't original designs, but they could put objects in here, and this device would sort them based on color, and they could program their robot to color, like notice by color, which one of these bins they need to pull back and do something with, and which ones they need to take to the dump and throw away because it couldn't be reused again. We actually talked my principal to let me take markers and draw out a coordinate grid on my classroom floor. So we did that, and I used rope for my X and Y axis, and then notice I just made the cracks in the floor brighter is really all that I did. And we labeled it and programmed robots to move so many units forward. It really helped students with coordinate plane plotting. It helped them with graphing, slope, different things of that nature. And, oh, sorry, yeah, go ahead. And there's a photo of the students working in the middle of the coordinate plane. I think they might actually be putting it together at that time, getting everything ready. We can go ahead now. Then we did some homemade obstacles. And there was students building things out of cardboard for the robots to work with. There's a BattleBot situation. They built Vex Robotics system robots, put them in the arena, and they played around with them, tried to flip the other one over. Little less sophisticated than some of the other stuff that we did, but they had a really good time with it. That's an original design a student did of a four-wheeler. That's not a kit piece. He designed. It had shocks. It functioned. It had a steering column that actually worked underneath it. So it was really neat how they could be creative enough to take pieces, put them together, and actually build something that could be used at a larger scale. This is a speed bot one of the students created. They use gear ratios using larger gears powering smaller gears to speed up a robot. So we actually had robots that normally travel at, I don't know, maybe a quarter mile an hour going 15 miles an hour because of the gear ratios they used. You couldn't keep up with them on foot because the kids had them going so fast using the mathematic gear ratio concept, which is an engineering concept. So there's a track robot, an original track robot design that students came up with to allow them to crawl over obstacles during a cleanup situation. I think that was a robot that was designed for speed, and they were actually going to have it. It wasn't finished when the photo was taken, but this was going to have a claw mechanism to pull stuff up with it. I think that was a battle bot. Not 100% sure that ever was fully functioning, but it was cool looking. I had two students actually that wanted to try to make a snake out of a robot to make it function and move, and they actually did that by piecing things together and using that robotics kit there. So the snake could actually slither once they were finished. It took a lot of fiddling around with it, but that's just one of the fun original designs I let them make. And that's a student holding one of the claw bots that we use in our BattleBots competition. Students' projects clearly indicated evidence of real-world applicable problem-solving skills. We have disasters around the world. There's messes after disasters. They program robots to shoot in there, clean them up. That's a real-world situation. That's a skill that could be useful in the future. That's something that kids could use to get jobs later on. It's experiences that they won't traditionally encounter in a regular classroom. I found that productive struggle leads to innovation. Instead of telling kids answers, I always said, what's wrong with it? Figure it out. And they did. 90% of the time, I tell them that. They go and they rework it, they move things around, and they figure out how to solve their own problems by asking the right questions. Students got hands-on experience in project-based learning environment that allowed them to be creative and innovative. And students successfully implemented and practiced the design process on their projects throughout the semester. CERT testing data indicated that all students that participated in this project showed substantial growth in mathematics from the first to second test session. And by substantial, I mean more than 4 points. As a class, they grew over 100, well over 100 points when you look at the aggregate of the whole group. Again, open-ended problem situations resulted in students asking better questions and being more innovative. Does anybody have any questions? Thank you.